I'm super fascinated. And I kind of have seen this kind of technology, I feel like, with, I don't know if you've ever seen the sports science segments, but those are usually done, which I'm assuming done with them.
Yeah, in a lab somewhere.
Yeah, it's not the way you make it sound like it's, I don't want to say on the fly, but it sounds close to on the fly, live, real time. I don't know. Give us an idea of how fast this is processing.
The cameras that we use are standard cameras. There's nothing actually special about the cameras. In fact, that was important for us as a technology to develop something that was camera agnostic. So in the case of Tokyo, for the broadcast, we've got cameras that are about 200 meters away. They're pretty far out there. They are tracking these sprinters, and we pull out a whole host of information. But what's useful from a broadcast standpoint are the metrics that everyone can understand. And so what's useful for a coach or athlete is a little different from what a fan might want to see. So for the broadcast, we pull out things like velocity, acceleration, when they hit their top speed. And then we look at that across the whole 100-meter stretch there. So you can see, for example, when an athlete hits her top speed. Or we can see something that's really, really fascinating, which is true for every 100-meter sprinter. They hit their top speed, and then they start to decelerate, and every athlete does it. So even when you look at Usain Bolt, right, you see his races, and he looks like he's pulling away, and you think that he's like kicking it up to another gear. He's actually not. He's actually slowing down, just not as much as his competitors. Really, really neat stories that you can't see until you look at the data like that.